Hello everyone, this is Mr. McMillan and I'm here with the instructional video for today. This time we're going to be talking about problems that involve diagonals in quadrilaterals. So we talked a lot about the various properties that diagonals have in quadrilaterals, as well as the angles and sides from the previous lesson. And now we're going to talk about the effects that diagonals have when we're trying to solve problems involving, rhombuses, quadrilaterals, parallelograms, all that stuff. Okay. So when a diagonal is drawn in a quadrilateral, there are two possibilities. We'll be looking at example problems that deal with each of these possibilities. The first possibility is that the diagonal splits the angles, but not equally. Okay, so any diagonal is going to split the angles and not necessarily in an equal manner. So this happens when looking at trapezoids, parallelograms, and rectangles. So the diagonal splits the angles, but not equally in trapezoids, parallelograms, and rectangles. So what we tend to do when we have those types of problems is we tend to rely on the fact that when a diagonal splits those shapes, it turns them into two triangles, regardless of what type of quadrilateral it is. And then we can use that information to help us solve the problems. And we'll be looking at those here in just a minute. The second possibility is that the diagonal bisects the opposite angles. This only happens when dealing with rhombuses and squares. Remember that when an angle is bisected, it is split into two congruent parts. And remember, congruent means equal. Okay. So let's look at some example problems and see how we would figure these out. So in number one, it says a rectangle is shown below. What is the value of X? And you'll see here, let me adjust the focus, I apologize. There we go. You'll see here that you want to find X in this rectangle. Well, we see that we have angles here. And so what else do we know about the angles of a rectangle? Well, the angles of a rectangle are all equal to 90 degrees. They're all right angles. And you'll notice that the diagonal here splits the rectangle into two right triangles. And if you remember, the sum of the angles in a triangle is equal to 180 degrees. Okay, so the sum of the angles in a triangle equal 180 degrees. So since 56, the right angle, and 8x minus 14 are all in the same triangle, we can add all three of those together. 8x minus 14 plus 56 plus 90, and set it equal to 180 degrees. And then we just solve our problem. So we have negative 14 plus 56 plus 90. When we add all of that together, we get 8x plus 132 is equal to 180. Our next step is to get rid of the 132 to get the 8x by itself. So we subtract 132 from both sides, and we get 8x equals 48. Divide both sides by 8, and we get that x is equal to 6. And if you want to plug that back in and check it, 48 minus 14 gives you 34. 34 plus 56 is 90, plus 90 is 180. Okay. Now, there are other ways to figure that out. You could also know that since all of these are right angles, and since these are parallel lines, this would be the same as 8x minus 14, and this would be the same as 56. So there are a bunch of different ways that you could do it, okay? So pick a way that makes sense to you. You could have added those two together and set them equal to 90. You know this is 56, and this has to be 90, so you know this has to be equal to 34. I don't know why it took me so long to think of that. And then you could solve from there. We'll give you the same thing, okay? Whichever way you choose, just make sure you understand how to solve it correctly. All right, number 2, it says parallelogram QRST is shown below. If x equals 6, what is the measure of angle R? So it gives you an x value here, and you'll see that that the angles Q and S have parts that have the x's in there. So to determine those angle measures, we need to plug x in. So 11 times x would be 11 times 6, which is 66. And then 8 times 6 would be 48. So those are our two angles. Now, the problem comes when we try to figure out what angle R is. Now, there are a few ways that we do this, but I'm going to show you the way that I prefer to do it. If we want to find out what angle R is, okay? If you remember from the previous lesson, we talked about angles in parallelograms and how opposite angles were congruent and consecutive angles were supplementary. So if you look here, we can actually figure out what angle T is using these two angles. And angle R and angle T are congruent because they're opposite, because they're opposite angles. So if angle R is congruent to angle T, and we find angle T, we'll know R right away. Well, just like the rectangle over here, we can see that when you draw a diagonal through a parallelogram, it splits it into two separate triangles. Each has a sum of 180 degrees. So to find the measure of angle T, we can take these two angles and subtract them from 180. So 180 minus 66 minus 48. And when you do that, you end up getting that T is equal to 66 degrees. And we said the angle R is congruent to angle T, so that would mean angle R would be the same, which is also 66 degrees. All right, number 3. Number 3, it says parallelogram LMNO is a rhombus with the measure of angle LOP equal to 36 degrees. This should say what is the measure of angle MLP, but I did not put a question there for some reason. So looking at number 3, it says that this is a rhombus. And you'll see that we have diagonals here that intersect. Now, the important thing there is the diagonals have another property for rhombuses, and that is that they are perpendicular. So we know that MO is perpendicular to LN. So right here, we have a bunch of 90-degree angles. Okay. Now, we want to find MLP. Now, MLP is right here. It's this angle there where that X is. It's not the whole thing, it's just part of it. Well, there's another property we know about diagonals in rhombuses, and that is that they bisect one another. So if we could find this angle here that's next to X, we know immediately what X is. Well, we know that this angle here is 36 degrees, and we know this angle here is 90. So if we draw, or we outline this shape, what shape do you see? And you should see that there is a triangle there. You have triangle LOP. And of course, since it's a triangle, the sum of the angles is equal to 180. So if we take the 36 and the 90, add them together and subtract them from 180, we can find the measure of angle OLP. So OLP would be equal to 180 minus 36 minus 90. And if we do that, we find that the measure of angle OLP is equal to 54. Is it 54? Yes, 54. Okay, so this angle is 54 degrees. And since these diagonals bisect the angles, that means that X must also be 54 degrees. So the measure of angle MLP is 54 degrees. All right, number 4. A rectangle is shown below. What is the measure of angle BCA? So we want to find BCA, which is here, BCA. So we want to find that angle there. Well, we know this is a rectangle, so we know that angle B and angle D are both 90 degrees. And that diagonal splits that into 2 right triangles. And we know that the interior angles of a triangle equals 180. So when we do 180 there, we know that X would have to equal 180 minus those 2 angles. So the measure of angle BCA is 180 minus 58 minus 90. So that means that the measure of angle BCA is going to be equal to 90 minus 58, which is 32 degrees. All right, next up, number 5. Parallelogram DEFG is a rhombus where the measure of angle FED is equal to 86 degrees. What is the measure of angle GDF? So if we look here, we want to find GDF. Now, is GDF a part or is it the whole thing? Well, it's just one part. It's just that part there. Now, we know this is a rhombus, okay? So we know something about the diagonals, and that is that the diagonals, well, they were perpendicular, but they also bisect the angles. So they bisect the angles. So if I could find a way to find D, I could figure out what X is because I know the diagonal splits it in half. Well, I have angle E and I want to find angle D. Now, we talked about this in the previous lesson as well. We talked about opposite and consecutive angles. And we talked about how consecutive angles were supplementary and opposite angles were congruent. And consecutive angles were attached by a side of the quadrilateral, whereas the other one was not. Okay, they're in opposite corners. So E and D here are connected by that side, so that means that they are consecutive. So D and E are consecutive. Now, since they're consecutive, that means that they add up to 180 degrees. So to find angle D, you take 180 and subtract 86, and you get 94. So angle D is 94 degrees. Well, that's the whole thing. We know the diagonals bisect the angles, which means they split them in half. So in order to find X, or GDF, we have to take our whole angle, which is 94, and divide by 2, which would give us 47 degrees. Okay? And number 6, a parallelogram is shown below. What is the value of x? So here we're given a 122 degree angle. This just says it's a parallelogram, so we don't know if the diagonals bisect the angle or not. So we can't say that these two are just equal to one another, so we have to do something else. Now there are a couple different ways you could go about this, and they both pretty much involve the same steps, okay? So you know that these two angles are part of this whole angle. So if you can determine the value of that whole angle there, you can figure out what x is from that. Well, if you look at this angle and this angle, you know that those are consecutive. And since they are consecutive, you know they add up to 180. So if you want to find this whole angle here, that whole angle would be 180 minus 122, which is 58. So the whole angle there is 58 degrees. Now you know that whole angle is 58 degrees. You know this part is 4x plus 10. This part is 32. So 4x plus 10 plus 32 must equal 58. Combine like terms on the left side and you get 4x plus 42 is equal to 58. Subtract 42 from both sides. You get 4x equals 16. Divide both sides by 4 and you get that x is equal to 4. The other way you could have set that one up, much the same, is you could take all three of these, the two parts in this one angle, add them together and set them equal to 180. Okay, that was the other way you could have done it. So those are problems that involve angles and the diagonals. Now let's look at problems that involve the diagonals and their measures, the segment measures for the diagonals themselves. So we need to know the shapes that have congruent diagonals, and these are the isosceles trapezoid, the rectangle, and the square. So those are the only three that have congruent diagonals. If we have a parallelogram or a rhombus, they do not have congruent diagonals. Then we want diagonals that bisect each other in quadrilaterals, okay? So again, this means the diagonals split one another into two congruent parts. And so the following quadrilaterals have bisecting diagonals, and these are the only ones that do, that we talked about. So we have a parallelogram, a rectangle, a rhombus, and a square. Okay. And using these two properties, we can determine what our measures are from any given problem that gives us either part of a diagonal or the whole thing. So let's look at number 7. Number 7 says rectangle ABCD has diagonals AC and BD that intersect at E. The length of BE is 210 inches, and so we see BE here would be 210. And the length of AB is 260 inches. What is the length of AC? So since this is a rectangle and we're looking for a diagonal, it's important that we determine our what's important for the diagonals. And so the properties that the diagonals of a rectangle have is that they're congruent. So the diagonals are congruent. So what that means in this case is that AC would be congruent to BD. So if we could find BD, then we could already know what AC is. We also know that the diagonals bisect one another. And when they bisect one another, what that means is that they split each other into equal parts. Okay, so that means that BE is congruent to DE, and AE is congruent to CE. So if the parts of the diagonal are congruent to one another, we can actually figure out what DE is. So since DE is congruent to BE, we know that DE is the same as BE, which means that DE is also 210 inches. Well, now we have two parts of BD, and we know that BD has to equal the two parts added together, so 210 plus 210, which gives you 420. And since we said the diagonals are congruent to one another, we said AC is equal to BD. That means that AC must also be 420 inches. And finally, number 8. Number 8, we have parallelogram QRST that's shown below. If QS is 102 centimeters and RT is 164 centimeters, determine the values of AS, AT, AR, and AQ. Now you'll notice here that QS and RT are diagonals. And this doesn't say it's a rhombus or a rectangle or anything like that. So what we need to do is determine, since it just says parallelogram, what the properties of the diagonals are. And the diagonals for a parallelogram are just the diagonals bisect one another. So that means SA would be the same as AQ and RA is the same as AT. Well, if we know QS and we know the diagonals bisect each other, we know that these two segments are half of what the whole thing is. So to find AS and AQ, we have to take QS and divide by 2. So that gives us 102 divided by 2, which is 51 centimeters. Similarly, to find AR and AQ, or sorry, AR and AT, excuse me, they are part of RT, so they have to be that diagonal divided by 2. So it has to be 164 divided by 2, which is 82 centimeters. And so we're just going to label those on the diagram here. And that's what we get for AS, AT, AR, and AQ. And that does it for this video, guys. I hope this video helped. We are going to try and wrap up quadrilaterals as soon as we can because we need to move on to our next thing, which would be circles. There is a worksheet posted, so please make sure that you complete that. Put your answers into the Google form that'll be posted tomorrow, and check your answers using that. Read the feedback if you get something wrong. The worksheet can be anything. It has anything on it, classifying properties, you know, things like that. So just make sure that you are aware of what you need to do for those. So I hope this video helped, guys, and if you need anything, just let me know. You can email me. We can schedule a Zoom session to talk about any problems you might be having with the content. But until next time, I'll see you in the next video.